Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Welcome to the coding and example section of chapter 8, which was on arrays uh, and strings, I think. So here we'll be talking arrays and C strings in particular. Sorry, this is not just string library, but the C strings that are available. So I'll basically be talking about the code and some of the examples from chapter 8 in particular. So let's start with the first of those examples. And I just need to maybe make a small quick comment over here that arrays are one of those particular data types that are most useful for a lot of different cases. And we'll see in a couple of examples how important they are and how they're used for different particular problems. So until data structures, maybe the one data type that you're going to be using the most, and even during the course of data structure itself, would be the data type of that we call array. So array would be one of the most useful data types for you, and this is kind of the one of those last important topics as well that we will be discussing. Of course, there is that pointers that is coming ahead, or that I've already recorded actually for you, since that was a very unique topic, as recursion. So those are the two topics that remain on my hot list at the moment. Graphics is something that I like to cover, as some of you had specifically requested, but I think graphics will not be included as it will not be evaluated for you. So if someone is interested to learn graphics, there'll be lecture on graphics for you, but I don't really expect you to be asked questions on graphics at all. However, since these topics, all the other topics will of course be included. We might also want to cover one or two more advanced topics like templates and like header files. How do you make your own header file and your own code file, CPP file and the .h file, and how they can be included in other files as well. That might be the topic that I will want to cover in this particular course. But otherwise, I'm not expecting. I'm not expecting anything else to be included in your final exams, other than the lectures that I've uploaded, as well as, of course, your projects that will be forming the major portion of your final exams. If we come back then to the problem at hand, which is arrays, and we've already discussed them in quite a lot of detail during my lecture, I'll just be going through some examples here. And those examples are, for example, what is the base address of an array? The thing that you say that if you want to get the address of the first element of your array, well, that is what we call the base address. For example, here are two arrays. One is called my list and one is your list. In my list, it has got 5 elements. In your list, it has also got 5 elements. My list starts from has basically 5 elements that are all even elements: 0, 2, 4, 6, and 8. Your list has not been initialized yet. It has been declared, but it has not been initialized yet. So the base address of my list is basically, if you just print my list out, it is going to give you the base address of your list, right? However, the base address of your list is also declared exactly in a similar way. So this is again how you can get the base address or the first address of your arrays here. So this is my list array, this is your list array, both are type integers, and they can contain 5 integers, and we're getting their sizes out. So and then we display if my list is equal to. So in this case, we are trying to compare the base addresses here, right? And the base comparison is based on the int value itself. So in the value that is returned, the base address, if it is equal to your list, then it returns the base address is same. If it is less than, it returns the base address is less than. Otherwise, it returns the base address is greater than. So this is just comparison on base address, not on the comparison between lists, right? And in one way, yes, you can compare lists, because if they have the same base address, same data type, and same starting point, then they pretty much have got their equivalent, or they're the same list actually. So the equal operator here will work absolutely fine with them. But otherwise, this will return a particular less than or greater than value. And in this case, what we notice is that the value that is returned is that it, first of all, it gives a warning that array comparison always evaluates to false. So this array comparison will always be false. Why? Because two lists cannot be equal unless it's the same list, right? Of course. So that's how, if you assign two lists, they'll always have different base addresses until and unless you basically actually have the same list being compared with itself. In that case, it will always be true, right? So that's why it is giving us a warning. And we notice that the address of both of them is actually different. So one is actually 5610 and the other is 565F0. And since both are different, the base address of my list is greater than the base address of your list. And we know that this is always false, because whenever you initialize two lists, they'll have different memory addresses. That's why it is giving us a warning as well, that this will always evaluate to false, right? And hence this is what, if you want to compare two lists, if you want to say if two lists are the same, not in terms of the number of elements. You might have declared my list as basically exactly the same as this one, but still the addresses would have been different and the results would always come either in here or in here. That's the first example for you where the base address was compared and shown to you. So this is basically, if I go with this particular program, it says that given the distance traveled by an object at every 10 units of time, this program determines the average speed of the object at each 10 units interval of the time. Okay, so if you give it the distance of object at every 10 units of time, the program will determine the average speed of the object during this time. And this is the average speed calculation. Again, we see a global variable being declared of type int, and which is constant with size 6. So you cannot change this size, and hence it's also capitalized. Here are some of the function prototypes that we see, for example, and here we see how maybe some of the arrays are being passed. So these arrays, you will know, are always passed by reference, and since they're passed by reference, any change that we do in them will be visible, right? So we see a couple of lists being passed. And then there are some of the functions. For example, you declare double of distance traveled, initialize it by size. Similarly, average speed by size. You use the manipulators here to show output in a particular manner. Then you basically perform the get data function. You pass it the probable parameters. You do the average speed function, and you do the print function with parameters, and then finally display them again using some particular functions, and that's it. And these are how to declare functions. Notice here that any change that is done in list is actually done with the reference. This means that the changes will be reflected in the original list. If you don't want that to happen, you should you should make a duplicate list of your own in the main function, and actually pass that duplicate list here, and so that every changes that are done in a duplicate list. And how you duplicate a list is very simple. Actually, you make a new list of the same size and then copy each element by element the values into that list. So that's the only way you can create a duplicate list, and any changes done in that duplicate will not affect the original one. So in this case, since we want the changes to happen in the original list, that's why we are using the list as our we have passed the list and we are using the list itself, right? So this is the way we are going to actually change the distance traveled list and store them in there by directly using this function and pass by reference as our to our benefit. Then you can calculate the average speed over time interval, and this is an example which shows that how you're updating the average speed, and you're taking values from list and putting them into the average speed. This changes the average speed, and that is exactly what is intended here. And this is how we're going to iterate over each element in the list as well. Then you've got the max average speed, which is the double average speed. Again, you won't want to change you don't want to change the average speed here, but instead just use it for iteration. So this is what we do. The max is the one that will be returned, and since max is the one that needs to be changed, that is the only thing that we declare here, and change it as we want to. In this case, notice that The average speed, nothing in that is going to change, since there is no operation which assigns a value to any element of average speed. Similarly, if you want to calculate the min average speed, it's the same function or similar function. And finally, it's a print function which performs some kind of manipulations and finally displays the values in a particular way, right? So you can enter the 6 values and then it does this all of this for you. So this is how the main example that you want to learn in this particular example is that the main thing that you want to learn in this particular example is that you want to see how arrays are passed to functions, how you can actually iterate over elements of the arrays, and how you can access them one at a time. And you should always refer to this example whenever you're doing, handling arrays in your projects, so that you're passing into the function correctly, you're getting the values returned from the functions correctly, and you're changing, when the function does change the values in your list, or when it does not change the values in your array. So that's the important thing here. Let's go to the next example, which is the average test score again. And we have seen this example quite a bit. If you are not using arrays, you'll be using something like this. So taking in five values and comparing, this is the whole code for average test score that you actually would perform if you were not using arrays, right? And in this case, the number of comparisons are that for each value you need to compare if it is less than average, and then output that this is an average test score, and so on. Excuse me. Yeah. So but with arrays this becomes much more easy, and we'll see in probably an example somewhere that does this with an array, and we'll see that soon probably. So yeah, let's go to the next example, which is the code detection example. And in this case, what we notice is this program determines whether a code is transmitted correctly. So there's a code that needs to be transmitted, and this particular program is going to check if that is transmitted correctly or not, right? So this is something that happens a lot of times with your programs when you're downloading. So over the web, when you're sending things or getting things, you're going to compare everything character by character, maybe from the one that's present with you and the one that is transmitted. So there is maybe a check code, and your program can actually compile that check code from your program and match it with the check code that it gets over the internet for the file that is present over there. And if both check codes match, well, the file was corrected correctly. Otherwise, the file is corrupt and might be needed to be resent again. It is actually the same for each and every packet of data that is being sent over the internet. So for each packet of data, you have got a check code, and with that check code, you can verify if the packet was retrieved correctly or if there's some error in the packet that was sent from the original user. So it's kind of similar code, but here what we notice is that there are a couple of operators that are passed by reference directly. The list is already automatically passed by reference, and then everything else is passed by reference, so that the changes that are done are kind of retained by the during the run. And we know that each of the input file stream and the output file streams, if you want to read and write or do things like that, you need to always pass them with the reference and not by value if you want them to work in other functions. And I'm not going to go into detail of how this function is actually being coded, because it's very simple. It's just kind of opening some input streams, opening some output streams, and passing them on to the functions, and then performing the relative task. And that's how this is working as a whole. And finally, of course, the thing that you need to do is the functions that over here are self-explanatory pretty much. So you basically either need to read the code or you need to compare them from different streams. And if they're by comparison, we mean if the values are exactly equal. We say that if the digits are exactly matching, we say the code digits are not are exactly the same. So we check for the next one. If code OK is still correct, that this is a flag, right? And this is set to false wherever we find some things are not matching. we say that there's an error in transmission and we need to retransmit. Otherwise, we say that every code digit actually matched for the check digits, and hence the transmission is fine and we receive the message correctly. And the next step, of course, after you receive a message is either to decode it or to try decrypt it, as you might have done in your discrete structure classes in chapter 4. Anyway, moving on to the next example, which is line and letter count. This is a program that reads the text, outputs the text as is, and also prints the number of lines and the number of times each letter appeared in the text. An uppercase letter and a lowercase letter are treated as being the same, that is, they are tallied together. So it reads all the letters, puts them up together, and notice that it uses the indexes of them, right? So that's the positive part here. That's the trick here. And this is what we need to do. There are some functions here that are declared. So for example, you input the file stream, you use the CC type as well, you include this file as well. If you remember, CC type is used to CC type was used for random functions, I guess, as well as a couple of other things, a couple of mathematical functions. I'm not really CC time was for time. Yes, CC type is basically for, I think, declaring typecasting. Okay, I've forgotten it a bit, but I think CC type was for, if I remember correctly, and you might need to check it out. CC type was for some kind of string operations. No, that was string. Anyway, I think you can search for CC. What does CC type library do? Maybe we can, one way we can learn about it is to uncomment it. Sorry, that's a comment type in other languages, right? So let's just comment it out and let's see what happens now. Which function is giving an error? Nope function. Let's run code and let's see which line is giving an error. And that is going to tell us what CC type function is doing over here. Well, it executed. Wow. Okay. This executes even without it. This was not required in this particular file anyway. So this is what it does. It reads the text in .txt file, which is this file, right? And it has got a particular paragraph that is printed over here, as you can see. And from this, it basically outputs it in text out.out, the same paragraph. And then finally, we see the number of lines is 15. A comes in 53 times, B comes in so on and so on. For each character, it is counting them in the method that was mentioned here, right? And this is the way it does it. So it includes some header files. I don't know CC type. You can maybe Google it out on your own and see what it does. For me, it works fine even without this one. So I don't think so we require this particular file for now, at least, and this header for now. So in the main code, we have got some functions like initialize, copy text, character count, write total. So these are different functions. These are the different, if file was not read correctly, we just output that it cannot be opened, return stop here. Otherwise, we continue with the output opening file. If we get the characters that are stored in first file, if and while this is true, while we are getting characters from input file, we use the copy text function, we increment the line count, and we get the next character from in file, and keep on doing this until the in file is true. Once this is false, the whole thing is written. We then write the total, basically, which writes out the line count and the letter count. You can see the letter count here is an array of 26 characters. So that's the exactly thing letter count over here. And finally, we basically close and return 0. The program is executed successfully. So when you initialize it, you basically are initializing the array every value in list by 0. That's the things that you do. And since you can see this is passed by reference, every change that you do here is going to be done in the real program. Similarly, since this is also passed by reference, everything that is done to line count, so for example, line count is equal to 0 is set here, will be done for line count as well. And then the next things are, you can use the input file stream in text to read the file, right? So you're going to read the file until you don't observe a new line character. You basically output it directly, and then you do the character count for that particular line, and then you get the next character and you continue on. So this is for until the next line is not counted. So this is a line by line streaming that is done here. And then you actually output the new line characters in the actual file, so that you know, the same file is reproduced, the same text is reproduced that is in the original file. However, the main thing here is that you are basically, notice here that you are passing character by address, you are passing out text and by address, and you're passing in text by address as well. The character count is being counted here. So for the character count, we see that for each character in the list, you are actually getting the index, and based on the index, you're calculating which index in the list to improve. So this is an index matching. You calculate the index by just converting the character into its possible string. And here's the thing. The index, when you convert a character into its int value, for capital A, it starts off with 66, right? And 66 is, if you subtract the int value of the character, if you remove 65, so it's 65, not 60, sorry, 65 is for A. So if you remove 65, it will automatically be, if matches A, it will be at 0, which is a position of capital A in the index. Otherwise, it will be the position of what you call the position of the character B or C or D or whatever in the list, right? So if it is 1, it is character B, and we know that if it is capital B here as character, the value returned from this int would be 66. 66 minus 65 is 1, which is also the index value, and that is the thing that we've used here. But notice this thing, the first thing that you do is to convert them to upper values, right? To upper, what does the function to upper do? It converts them to the corresponding uppercase. And when this converts to the uppercase, everything now is in uppercase, and then all we need to do is convert all these uppercase letters into subtract the values of 66 from 65 from them to get the corresponding position or the index. And if this is true, if the index is between these values, you just output you just increment the count of the characters in the list. And of course, finally, you need to write them. And for writing, once everything is done, then after the whole input has been processed, the totals are written and everything else is ready in the program, we then need to write them out into the file. And for writing, this is what we do. We write a total number of lines first, and then followed by, for each particular alphabet. And here, this is the opposite part here. So now you're calculating the index plus the static cast int, right? So you're adding this into it, and this gives you the position, and you just write out the total of things into count. You can see that you increment index by A, 65 again, to get the original character. For each character here, the count is this, and this is the simple program. But you can notice that how we have intelligently used the conversion of character ASCII value to its index in the list, as well as the opposite process where we converted where we calculated the index first, where we use the index to calculate the ASCII value of the character, and then converted that ASCII value into its corresponding character directly. So all of this is very interesting and very intelligently done in this particular problem. And these are some of the typical problems that one faces when he's trying to work on with lists and with indexing, in particular with characters. And in this case, we took up a text. This is the exact field of what you call encryption or decryption, for example, or yeah, even if you want to transmit data over some pipeline or something, you can use these kind of things. If you want to take up a stream and write it out into different places, again, while calculating statistics along the way, this is the way you're going to do it. So let's move on to the next example, which is basically range-based max. And in this case, there are some number lists that are given, right, within a particular range, and you want to calculate the maximum number within that range. And these are again simple functions. I don't want to go into details over here. However, there is one thing that I want to talk about, and that is the pointer operation over here. You have already gone through the pointer lectures now, and you'll be able to identify what this int static p is doing. This is calculating a pointer, and with that pointer, it's basically we also see another thing that we discussed in the chapter, which is the auto function. So this is what I said. It says that declare number as any number, right? So and loop it over for each value of x, right? So for each value that is present in x, you want to loop it out. And if num is greater than max num, then replace max num with num and continue on this loop. So this is another way you can declare loops using the auto and basically what I call the iterators in C++. And this functionality, you need to remember, is only going to run if you use C++11 in your code. So let me try it. I don't think so I've got the C++11 installed. And if that is not done, well, this is the exact thing it is saying. So auto range-based for loop is something that is only possible in C++11. This is an exact example of how it is using the auto loop over here, right? So this is something that is only available in C++11. In my case, since C++11 is actually installed, this is working fine. If it was not installed, I thought it was not installed. Maybe I can check the version of C++ here, right? So the version of C++ here is that I'm using is GCC, I think. So let me check if I'm using GCC or G++ in this code. I'm using G++, right? So let me check which version of G++ I'm using. So it's configured with blah, 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 blah. Apple CLang version is 11.0.3, which is, yeah, so I'm using C++11 for sure. And hence, the version, at least that I'm using, is C++ version 11.0.3. So that's a good part that I was already using it, and hence it works. If you get an error here, you'll know that that is because you're not using the latest version of C++. Kindly update your language to the C++ at least to version 11, and you'll notice that if you use the line here that I use, G++ is typical for Mac. I think a similar one might also exist for Windows, and you just need to check its version by giving it -v as its argument. And if you do that on a command line, like I showed you how you can run your programs from command line, this is again something that would be helpful to you. Okay, so moving on to the next example, which is select sort. So this is an example of selection sort, how sorting is done. We already know that sorting is a very trivial problem. It is a very basic problem that was there since hundreds of years at least, or maybe a few, even 1,000 years earlier. Since sorting is a very common thing, and you are given a list of numbers and you want to sort them in a particular order. One algorithm for sorting a particular list is what we call the selection sort algorithm. And how the selection sort operates is that it basically determines the index of the smallest number, and then it simply swaps them using simple swapping operators, like using temp operators. Finds it replaces in temp it stores the smallest index value, then it basically simply it puts it at the right index, and then the index value is then swapped by the smallest value. So it basically shifts, it selects the smallest index, puts it into the right place, and then it moves on to the so let's say the smallest index of these three is over here, and this one it basically keeps this in temp, this in temp, this one is the smallest one, it then puts this directly over here, and the value stored in temp will be put over here, and then it's going to start from second position. This is now the next position that needs to be fixed in, and then it will put in at the corresponding place, and so on. This is how the selection sort simply works. And here is an algorithm for you to see how a nested for loop works, and how we can actually do it using a simple sort by just shifting each character by character, each position by position, and then for each position we'll determine its position and put in the corresponding values. So in here we see for the list, we first input the list, then we perform the selection sort for the list. Notice that when a list is passed to an array, this is always by reference. Hence, any changes that are done in list are actually actual changes. And since you are changing the list over here, so these changes are all actually, these two changes here are actually changes that are done with the actual list. And in this case, we notice that ultimately, let's just, if I run this code, I'll notice that the list is unsorted 2, 56, 34, and so on. And after printing, it is now in a sorted form 2, 5, 10, 16, 25, 34, 46, 56, 73, and 89 for you. So that's how this particular thing is operating. And that's how we see that the selection sort is working. It sorts them in the particular order. And finally, then we display them using the for loop again. We access them and display them in the same order. Notice that to access each individual member of the list, you need to use an iterator. For example, the for loop here, start from position 0. The list always starts from position 0 and goes on till n-1. In this case, since we know that we have 10 elements here, so we go till 9 and we access 0 to 9 positions and print them out. In selection sort, we actually did the opposite, where we started from basically position 0, went all till 9 over here, whatever the length here was 10, so we went on till 9, and inside in the inner loop we actually start from index plus 1. So whatever the index is, we always go from one position ahead, and this is what the position that we need to swap. The next position, the next smallest integer, will always be placed in this particular index. So at the start, at this particular location, so at the start, when the index is 0, it will be put at position 0, right? But afterwards, it will always be, the location is always going to be 1 ahead. Okay, so once we are done with the selection sort, let's go to example 8.4, which is relatively trivial. And what it does is it calculates the average score again. And this is when we are using arrays for it. If you remember the previous code that I showed you, where we are calculating average test scores in here, I think. So here we use these if conditions, lots of if conditions to get these. We are using a lot of cins to get the individual values, and each of these variable names needs to be remembered. You might put an error, and you might write test 0 somewhere, or the indexing goes wrong. Maybe the comparison, you might miss one comparison here, since there are so many comparisons to make. Think of these as just 5 test scores. What if there were 100 test scores, or even 1,000 test scores? There's a lot of chance, if you're using this kind of structure, you're going to make a lot of errors. But if you come to this particular example with arrays, it doesn't matter how many number of examples you need to take, number of test scores, number of comparisons you need to make. They can all be made simply in 2 for loops for you, an array and two for loops. One basically for getting the input, second basically for outputting the scores, and that's it. So for getting input, you can use a for array. For getting output, you can use a for array, and it works for loop for both, and they work absolutely fine with arrays. And this is something that I've really loved about arrays, that very trivial task that would take a lot of time and have a lot of possibility of human error involved. Loops actually take that out of your hand and make sure that you don't have those errors. However, loops do introduce their own type of errors, which we will see later, probably index out of bounds errors and examples of those. But maybe with indexing as well, you need to know that you need to. It takes a bit of practice and a lot of time as well to kind of understand that arrays are beginning at position 0 and going on to position n-1 in C++. Maybe in other programming languages like Python or other languages, we might see that they start at 1 and go on till the size n. So in those cases, it's slightly different, but at least for C++, we know that indexing is a bit of an issue, or a bit different. It's not an issue. It's a bit different from the traditional thinking of starting at 1 and going on till the position n. Other than that, I think you need to be aware that arrays and strings make your life a lot easier for a lot of different kind of options. And this is something that I needed to point out over here before moving on to the next example. So in this case, the array to be initialized and its size are passed as parameters. The parameters list size specifies the number of elements to be initialized. So we want to initialize an array with some values, and fill array, print array, some functions like sum array, int index largest element, and then copy array, right? And you got, these are some of the functions for arrays. It does not contain a main function, as I can see, and hence we cannot run it, I think. Is there a main function? Probably not. Hence these are just functions that are there, and I'll just verify if it is exactly the thing. Yes, I noticed that it does not contain a main function, and hence this cannot run on its own, but it shows some of the typical operations that can be done with an array. So for example, if you want to initialize an array with all zeros, you can use a for loop and index operator to change all values inside a function and initialize it by 0, or of whatever particular value you want to initialize it with. So this is a function which gets two parameters. One is the actual list and the other is the list size. And you need to remember to use this function. So these are some of the very common functions that are going to be used, but they make your life a lot easier. So you can just copy paste this code exactly as it is and use these functions. These are built in for you. If you want to initialize array with particular values, for example, with zeros here, you can use this function. If you want to fill your array and get input from user, you can use this particular function. And these will be reflected in the actual one as well, right? So for printing, notice that we have declared this list as constant. So in this case, the changes will not be able to change the values in the list. And this is something that I told you: if you don't want the values to be changed in your list, always use the operator constant within your list. It need not be a constant before. It is going to generate a bit of a warning that you're passing a normal list into a constant list, but this kind of makes sure that you're not changing anything in the code. So this is a good operator. Then you've got functions that are going to sum all the elements of the array, and this is again an important function for summing up the whole arrays. Then you've got index largest element as a possible function that needs to be passed. Again, this is like the index. This is going to return the index of the largest element that is present in your function. And since we don't want to change the actual function, we have declared them constant in both of these functions as well. And finally, you might want to make a copy of the array. So you are given two arrays. One you want to change actually, and the other you might not want to change. I would have ideally declared the list that I don't want to change, which is list 1, to a const as well. And in that case, I'm just copying the value here and then incrementing my corresponding location or integer, and I'm going to run it starting from the source point till the number of elements which I want to improve, and get my new position out, which is TAR, and just increment it with each step. And yeah, so this is something that is going to these are some of the few functions that are extremely useful in arrays. If you want to copy something, a portion of array into another array, for example, you can use the copy array function. If you want to copy the whole array into another array, you can again use the copy array function with its corresponding indexes and sizes. You can actually determine the largest element. You can determine the smallest element if you write a similar function. For smallest, sum array, print array, these are some of the very commonly used and very important functions that you will be using throughout your programming life, or maybe from now on till if you stuck with programming anywhere in your software house or anywhere, these functions are what you can basically just copy paste, written for you to use wherever you want. So here is another thing, another common algorithm that we normally require is the search algorithm. And searching is again a very, very common task, just like sorting is. So for searching, here's a sequential, it's the simplest sequential search algorithm, which basically gets a list of an array. And in the list, if it tries to find a particular element, initialize the position by -1 at the start, and if we can't find it, the position will remain -1. If we find it at a particular position, that position is going to be outputted, and we say that okay, the thing was found at that particular location. So this is what we do. This is the main function that performs our search, and what we notice here is that it takes a constant int list, so this list cannot be changed, should not be changed in the code. It takes the list length. So it starts from while the location is less than list length and not found. It is not found, as well as the list is this. We keep on running is found. If it is found at some location, we simply turn location is found is equal to true and return the location. Otherwise, we just increment the location and go to the next location and check the element there. So this is a very simple code that sequentially starts from the first position, goes on to the last position, and searches for a particular element. So let's go to the next example, which is example 8-11. And this example is basically how lists are, or how double lists, multi-dimensional list, for example, a two-dimensional list is declared here, how it is declared and how it is going to be passed and how it is going to be used in our programming. Of course, we know that to access, for example, to print a multi-dimensional list, we need as many for loops, as many nested for loops as the number of dimensions. Since in this case it is a two-dimensional list, we're going to use 2 for loops, and so on. This one can continue on, and basically this is the way it works. For the whole access largest in rows, for example, for each row, if you want to find the largest element, this is the way this is going to work. This is the code that actually works for a single dimensional array, and if you want to use it for 2D, you just need to add this for loop, determine the largest one for each row, and then maybe just print it out. This is the place where if you want to find the sum of row, again the same thing for the row. For each row here, you just perform the sum operator, and this is the sum operator for a single that you could have used for a single array as well, however with the appropriate indexing for the row here. So if you remove row, for example, and this would work like a charm for a single row. However, in this case, this is like this is for a single array. So in this case, it's basically done for 2D array, or a matrix as you want to call it. If you want to print them, so this is a nested for loop again, and this is something that I've already explained, and these are the simple functions. Whatever the input is on the board, you just use these different functions, put an end line, next line, and just print these values out. So really simple, really good. And if you run this code, you'll see that you have these values that are in the board, and you can just print out. So these are the sum of rows. This is the actual print of the matrix, which is formulated or using or manipulated using IOMAN IP, as we have seen. So this is sum of each row, and this is the largest element of each row. For example, the first one largest element is 23, second is 67 and 76, and so on. So these are the largest elements in each row. So you see the nested for loops are the important characteristics for multi-dimensional arrays, and this is something that you need to take a lot of care of when you're writing your code. Specifically, if this is row-oriented code, you could have written it in terms of columns as well if you wanted to. However, it is always more convenient to use rows because that is more naturally, we can get that concept more naturally as compared to columns. Columns are a bit odd for humans to deal with at times. However, we can do that in code as well if needed. So this is how you're going to deal with multi-dimensional arrays in C++ or in any other programming language. These are the concepts you need to know very well. So let's try the other part of the code, and let's actually start first with the C strings so that we are more aware of them. So for example, let's say here is how a C string is going to be declared. Here's an array of type characters, and this is what we call the C strings. So it has A, B, C, D, E. Let X be 50, let Y be -30, and then if you simply see out name, name is going to be A, B, C, D, E. So these are how you declare a character array, a string, a C string, or a character array, and then you can simply display it out directly. So if you run this code, this is the value that you're going to get. You actually output the name, and unlike other arrays, which are not C string, unlike other numerical arrays, if you output the other numerical arrays, the value here would be the starting position or location of the array. But if you are using a character array, a C string array, in that case, it is going to display them together as a string value, A, B, C, D, E, whatever the values that are stored in that particular character array. So notice the major difference between a character array and an integer array. Like I said in my lecture as well, a character array is going to output the values that are stored in the list as a string, as a single string. However, an integer array or any value array that contains decimals like float or double or maybe int would basically, a numerical array I should call it, would output the starting address, the base address of your memory, and that is exactly what we just saw here. So for each of these, which is an integer array, we were able to find the starting address. But if you talk about the character arrays, it would basically display the string instead of the starting or the base address. Then if you move on to the next example here, which is basically, now we actually move on to other examples here, which are more related to what you call types of errors. So these are indexing errors. These are, here you're trying to access an array and you are accessing it out of the boundaries. For example, in this case, if we just go through this, A is 18, list is 10, B is -20, and int x4. So you want to, this is something that that has not been initialized yet, right? So this is a problem with initialization. You're trying to access x4 before you have initialized it, and you want to store it somewhere, which is really odd, right? So sorry, in this case, you're not trying to access it, you're trying to declare an array of size 4, but the default values have not been initialized. So the array has not been initialized, it has just been declared. So declaration is fine, this is right, int x4, int x is an array of size 4 and it is of data type int. However, the 4 integers have not been at least input until this line was declared. This is an empty array. Then if you move on to the second line, which says that I is equal to 0, I is less than 10, I plus plus, and then this is, you're going to initialize each element in the list by a value 0. So each element in the list is initialized by its value 0. So we now output A as 18, B as -20. So now what we try to do is xi is equal to 0, I is less than 4, I plus plus, and in this case, output the values that are stored in xi. So since this has not been initialized, this is going to either give an error or show really junk values for it. I think this is, in this case, it is going to show junk values, but it depends on the compiler, on the C++ language version, as well as the IDE that you're using, how the behavior will be for this particular line. For the next line, again, we declare the 10 values and we try to, this has been initialized, right? So then we can use these. So again, sorry, the character has not been initialized again, and this is an empty. So now you're trying to display these values here. Notice that in character arrays, again, difference is that if it is empty, the output will be an empty string. It won't be an error. It won't be junk values. But the ones that are that are going to be used for xi, for the integer array here, these are going to be junk values. So these are going to be junk values. These are going to be the empty list. And let's run it and see if that is true. It depends on the compiler as well. So I'm not going to really go into detail. In C++ language 11, it actually shows that for each of the 4 values that are going to be displayed are basically null for characters as well, right? So there's nothing here. And on the other hand, for each of the 10 values that got displayed here, it's basically the values here are 0, 1, 0, 0, some junk values, some really odd values that are not stored at all in the particular array. So if you really want to, initialize things correctly and use good addresses, always initialize the arrays with proper values so that they do not pick up a junk value or do not behave unexpectedly. If you want to initialize arrays by default with 0, you can do that just by simple declaration. But if you do that, I think that is very much dependent on your C++ language version and the standard you are using. So I would never advise you to, leave or use actually undeclared variables. Always declare them, always initialize them, and then use them. If you are using uninitialized variables, they may cause unexpected behavior on different languages. Your code might be running fine for you. If I run it, the same code is going to behave differently. And that is because of you have used programming practices that are not standard. And this is one example of using uninitialized variables. It's not a standard programming practice and something that we should avoid by all means, right? So here is another thing. An array index is out of bound for list 2, right? So you have declared a list of size 2. It can contain 2 elements. The first 2 elements are 5 or 10. You're trying to access the array index, which is out of bounds. And then basically you're then trying to display the values. So let's see how this code runs. I think the first 2 will be stored there. The third line is going to generate an error and abort right away. And that's exactly what we see, right? So in this case, as soon as we first encountered, we tried to access an unwanted region, we actually we got an error and we quit right away, although the value still got displayed. So it runs, yes, but it is ultimately going to, when it tries to write out to the third location, it will probably abort, since that memory location is either not accessible or should not be used directly. So here's a third example. In this case, this is an example that runs fine. And we'll see that once you run it, there are 2 locations, 2 things that are to be stored, and this is absolutely fine. However, when you try to print that out, you're still accessing a location that is not correct. Counter is not, when it is equal to 2, this is going to abort and cause a segmentation fault. And this is exactly what it does. It does read the value, but that value that is read is actually a junk value. So this is not 0 as you wanted it to be, right? And this is something that I've mentioned, that when you declare variables, when you try to access them directly, this may lead to very unexpected behaviors at most times. And that is why I'm not very happy with how, if you do not, first of all, never ever access an index variable that is out of bound. Sometimes the compiler may give you an error, the segmentation fault. At other times, it may behave pretty normally, apparently, but the values that it is going to retrieve are going to be junk values, and hence your whole accuracy of your program, the way it's worked, the way, for example, sum or other operators are going to work, are going to be absolutely crazy. And or maybe even the maximum or minimum or whatever you're trying to find in your array, it is going to take up values that are not there, and hence it may be affected by it. And for that very reason, I'm not going to recommend to you to use things that are out of bounds. Number one, make sure you are within bounds. Number two, make sure that you initialize arrays properly with zeros or with values, whatever you want the null value to be, so that you are aware that throughout the execution of the program, that your all your arrays have been correctly initialized. Initialization is a big issue. And then of course the second issue is the access one, where the indexing becomes important, and in that case an index out of bound is one of the most common errors, particularly when you set it equal to the size of the array. So that element should never be accessed, it should always be less than the size of the array. Since the indexing always starts from position 0, one position behind the actual position, so it also ends one position behind the size of the array. And hence it should always be until the access variable runs till the size of the array, and actually less than the size of the array, we are absolutely fine. As soon as it becomes equal to or greater than size of the array, we are, strange things are bound to happen. It may return a segmentation fault depending on your compiler and language version, or it may give you a value that is a junk value, and you will never ever actually come to know what is wrong here unless you actually debug it, and then you finally realize that the size was incorrect, and hence the junk value was being counted every time. So maybe if you're calculating averages, the averages would be really strange in different runs. And if you encounter that kind of a problem, it's not a random problem, it's not a problem with the compiler, it's a problem that you are reading things from random memory places, which you should not actually access, and it is basically a problem with your array size. So if you're observing random behaviors at different points in your code, there are two things that you need to remember. One thing is that it is either the random function that you're using in your code. If you're not using any random function and you're still observing a random behavior, it might have to do with your array indexing, where it is taking up junk values from random memory locations. So these are a couple of pointers for using arrays and C strings as well. I hope you've learned something about arrays and C strings during this lecture. The main concepts here are going to be pretty useful for you throughout your life, throughout your programming life. If you have a limited life, well, that's it then. But otherwise, if you are at least you are going to at least use it throughout your 4 years of stay at GIK Institute, and probably even beyond, even if you go to the software industry, or if you go to the for higher education and come back, sometimes later to the academia, even after that, after your PhD, and after the software houses, you'll probably be using it throughout your life. So these are some of the pointers and some of the things regarding arrays that you need to keep in mind when you're using them. An array index out of bound is the most common error. It's the most common thing that we usually make a mistake with. Array initialization is another most common mistake that we make, although these two are very simple things and can simply be handled by loops. And the life is made much easier by using arrays, since we don't have to write the same piece of code for each single data type, and an array will actually help us in this particular regard. The other thing with arrays is that it unifies all the related elements together in the same list. So it helps us as well to retain everything together in a single data type, rather than it being spread over in multiple different locations. So that's the beauty of arrays. I hope and wish all the best for you with arrays and C strings, with pointers, with functions, with loops, with the basic conditions and everything else that we have studied throughout the course so far. And I really hope that you are learning from these lectures about programming and a lot of basic things about how a particular program or your computer is behaving, why that is very much standard normal behavior, as compared to it's not magic that is going on in programs. And these simple programming techniques and tactics and concepts would actually help you develop a better understanding of how even a word processor, for example, is operating. For example, how your Windows is operating, how a particular program that you run, maybe a game, maybe a movie, how that is running, what's the underlying mechanism with which it is operating. And this is not magic. This is all structured and very much intended use. So, and to better appreciate it, I would really say that you should learn how computers and how programs and how things looked back in 1970 or 1960s, right? Early 60, let's say, or even 50s for that matter. And how things have changed, in within these 50 odd years, 60 odd years to the state where we are now. And the beauty of, the screens and automated life and every other thing you're seeing is basically down to the programming. Although I would again say that C++ is a programming language for a particular purpose. It's a low-level programming language as compared to, let's say, the more interpreter-based languages like Python and R and MATLAB and other languages which are more higher level at least than C++, and are more compact, and you need to write much less code. But at the same time, I think since you are going to be in computer science and AI for the better part of your next life, probably, or at least for the next 4 years while you are studying here with me, around me, or maybe at JIK. So during that time, you'll need to um, go through these concepts quite a lot. And for that reason, I really recommend that C++, you understand the concepts of C and C++ very well. And if you learn the concepts, you'll be able to apply them throughout your programming life, shelf life. And yeah, that's pretty much about it from my side. I wish you all the best for your programming and for your next lecture, which is going to be on recursion and how recursion works and why it is important, and how it is different from the traditional function calling in functions. So see you in the next lecture. Take care. All the best. Allah Hafiz.